Okay, so um, this is RSG 10. I'm actually going to start with the Go. Let's give you a couple um, examples, but also just ideas with this. So, the first part of the Go is having you multiply each of the binomials using the distributive property. So, when you have two pairs of binomials like this, these are in factored form. And when you distribute and multiply and use that distributive property, we're moving it from factored form to standard form. And this is useful. I'll show you, it's in the ready of this RSG, why it's useful to be able to go from factored to standard. And then from standard, you can go and move it to vertex form. And it really needs to go in this kind of order. Okay. So, like I said, in the first part here, we're going to multiply each of these using the distributive property, and it'll move it to standard form. So as far as distribution goes, I've done this plenty of times. The first term times the first term times the second term there, and then second term times the first term, second term times the second term. And we're multiplying. So x times x gives us x squared. X times negative 4 gives us negative 4x. Positive 16x, 16 times x gives you positive 16x. And positive 16 times negative 4 would give us a negative 64. Once we're at that point, we can look at our like terms here. I know they're like terms because they're the only one with x's in them. You can combine those. That just means add them. Negative 4x plus 16x would give you a positive 12x. And what we have left over is we still have that negative 64 on one end, and we have x squared on the other. Okay, so we've now moved this from factored form to standard form. Again, why this is useful is that, if you remember from RSG 9, factored form gives us the x-intercepts. We have x-intercepts based on this at negative 16, 0, and positive 4, 0. Take the opposite of the signs going from the equation to the graph. Okay? And in standard form, we get our y-intercepts. Our y-intercepts are given by the c value. So this is our y-intercept at 0, negative 64. So that's what standard form is useful for. That's what factored form is useful for. So that's why we would go from factored form to standard form. So down here, we're given expressions that they'd like us to factor them. Now, it says if you can't factor it, then don't factor it. I'll find one that you can't factor, and instead, we'll complete the square. Okay, so let me see. I'll tell you this. I think this very first one, let me think, isn't factorable. Oh no, yeah it is. This one's factorable, okay? Can factor that one. That one's factorable. Oops. Okay. That one you can factor. that one you can factor. Okay, there are a lot more. I'm gonna say 19 you probably can't factor. Okay. So 19 we can't factor, and this is what I'm looking at, right? We look at the C term, -1, and what times what would give you -1, but then adds together to give you that B term. The only factors for -1 would be -1 and +1. Those are the only two factors for those. -1 plus 1 gives you 0. So does not equal -3. So this one's not factorable. So what we'll do instead, just to give you an example, because this is something you'll have to do on your exam on Friday, is if it's not factorable, then maybe we can complete the square. And not everything's going to be factorable. The idea, remember, when it's in factored form, it gives you your x-intercepts for the parabola. Well, if it's not factorable, you didn't make a mistake, but chances are that parabola is maybe above. And so there are no x-intercepts, or maybe it's below and pointed downwards. So there are no x-intercepts, okay? It's totally plausible. So this one doesn't factor, meaning it doesn't have any x-intercepts. So what we can try instead is find the vertex form, and therefore find, we'll complete the square, and then we can find the vertex. Every parabola does have a vertex. Can't get out of that one. So I'll put my parentheses around the two terms. If it helps, you can change those to x's. Letters are just variables, doesn't matter. So we've got x squared minus 3x. I'll add in that blank space, and then we have -1 on the outside. Get this into vertex form, we got to divide that by 2 and start creating my vertex form. -3/2 squared. Once we square that 3/2, that gives us 3 squared over 2 squared, or in other words, 9/4. That goes back up here. If I add 9/4 inside, I've got to subtract 9/4 on the outside. 9/4, that's the same thing as 2 1/4, 2.25. And I'm subtracting that, so that would give us -3.25. That's what goes on the outside here. So there it's in vertex form. Remember, vertex form is handy because vertex form gives you where the vertex is. Opposite of what's in the middle. So our vertex is at +3/2, which I guess I'll write it as 1.5. And then -3.25 in the y direction. So roughly that would put it maybe about here. 1.5, -3.25. Okay. Oh, and I messed up there because it shouldn't have x-intercepts. Where did I mess up? Shoot, I don't know. I guess it could still have its x-intercepts. It's just not factorable in nice numbers. Okay. Anyway. Looking at these, this one is not factorable. This one is factorable. This one is factorable. This one is not factorable. So see if you can't complete the square on these guys that I circled in red. The rest are factorable though. Okay, so I'm going to jump back up to the ready. Ready. We've got a story problem here. They've given us this equation. Okay. And it's talking about a golf ball being driven off the side of a cliff. And they tell you. So they've moved these three are all the exact same thing. They're all equivalent to this. They've given it to you in standard form, given it to you in factored form, given it to you in vertex form. So standard form, like I already said, this gives you your y-intercept. Or, in other words, when x equals 0. Factored form, that's going to give you the x-intercepts. X-intercepts, there can be 0, 1, or 2 x-intercepts. Any one of those three. Can't have more than 2, can't have less than 0. And then your vertex form, that gives you the vertex, which is either a minimum or a maximum, depending if your parabola is opening upwards, that would give you a minimum, or if it's going downwards, it's a maximum. Well, looking at this a value is negative, we already know that this is going to look like this. It's got a negative a value, so it's opening downwards. We're going to have a maximum. Okay? So with that kind of information, answer the questions. And then our set, there we're given quadratic equations in several different forms. You've got your factored form. Already showed you how to move it from factored form to standard form. And then from standard form to vertex form, you have to complete the square. So these are pretty involved. And then you'll graph them. But once you graph it, you've got all the points you need. You've got your x-intercepts. You'll have your y-intercept. You'll have your vertex point. That's 4 different points already. Okay, so you should be able to graph it pretty easily. Vertex form, if you want to move it into standard form, first thing you need to do is expand this part. What I mean by expand that is x minus 1 squared. That's just, let's do a different color. X minus 1 squared is just x minus 1 times x minus 1. And then you have your plus 3. So I've expanded it. From there, focus on just this piece at first. Do your distribution. Okay. And then you'll distribute your 3. Gives you, after I've expanded it and combined my like terms, you would have x squared minus 2x plus 1. That plus 3 is still hanging out. Then you would distribute that 3 through, all 3. 3x squared minus 6x plus 3. Then you still have that other plus 3 just hanging out. So our standard form in this case would be 3x squared minus 6x plus 6. Okay. Y equals. So that's what you do with vertex form. From there, you guys can factor it. And again, start graphing. And then last, well not last, but number 8, this is in standard form. Complete the square first. You can go from standard to vertex once you complete the square. To go from standard form to factored form, you'll have to factor, answer the question, graph it. Number 9, this one's a little tricky. I'm going to zoom in. We can't get our vertex form because we can't tell exactly where that's at. But you can tell where your x-intercepts are at. Okay. So that should get you started. You can get your x-intercept, so therefore we can get factored form from that. You also got your y-intercept. That'll help you come up with parts of your standard form, or at least you can check yourself. Your standard form C value should be at 6. That could also help you get your factored form. So anyway, put the pieces together, see if you can't come up with those. Number 10 gives us a table with quadratics. You always want to look for the sandwich. That's how you get your vertex, and you can graph that. And there's your set. Okay. So again, if you have any questions, be sure to email me, wetstema@sd25.us. Okay. Good luck.